All right, so today we are going to go ahead and we're going to start working on how to make box and whisker plots. But there's a lot of prep work that goes into making a box and whisker plot when we start with our data. So we're going to go ahead and do that prep work in this video. And as you can see, when we start with raw data, the first thing we need to do to make our box and whisker plot is order it from smallest to largest, because we're going to need our median and we need to order it from smallest to largest in order to find that stuff. So I've taken the liberty of ordering this set of test scores from smallest to largest from 0 to 100. And we need to find the 5 values listed below, the 5-number summary, and then our IQR, which we'll use to calculate our outlier fences, and then determine what, if any, outliers we have. And we will need all of this information to make our box and whisker plot. Now, our maximum is pretty easy to find in the data because it's the number that's the farthest to the right when it's ordered from smallest to largest, aka 100. And on a test, it shouldn't be a surprise that our max is 100. Our min, on the other hand, in this example is a 0. So those are our minimum and maximum scores. Now let's go ahead and find our median. So to find the median, I'm just going to cross off one number on each end until we arrive at the center. So 0 and 100 go away, 48 and 100, 59 and 95, 61 and 90, 67 and 84, 51 and 84, 72 and 81, 72 and 75. So the last pair of numbers we're left with here in the middle is 75 and 75. Now, normally you would need to take the average of your two middle numbers when you end up with 2 in the middle. That happens in in a data set with an even number of numbers. This data set has 18 data points in it. But conveniently, 75 and 75 are the same, so we can simply say our median is 75. Now what we need to do is we need to calculate Q1 and Q3. And Q1 and Q3 are known as being quartiles, quartile 1 and quartile 3. Q2 is also technically quartile 2, but almost no one ever refers to it as that. They just call it the median because that's what it is. But Q1 and Q3 represent, essentially speaking, the 25th percentile of the data set and the 75th percentile of the data set, whereas our median is the 50th percentile because it's right, it's the number that splits our data. So if you think about it that way, Q1 and Q3 are like the median of the lower half and upper half of our data set respectively. So we're going to go ahead and calculate our Q1 and Q3 using pretty much the same method we just did. So 75 and 75. 75, one of the 75s is going to belong to the upper half of the data set, and one of the 75s will belong to the lower half. If we had had a single number that was our median, in that case, that number would have been excluded from each half of our data. But since we didn't have a true median in this one, we had two numbers which we had to average to get that median. One of the 75s goes in the top and the other one goes in the bottom of the data set. So as you can see, I've now split my data into 2 equal halves. If we had had an odd number of data, the median would have been excluded, and by excluding the median, then we would have had 2 equal halves to the data, minus 1 data point. In any event, actually finding what the median is in each half is super straightforward. We begin with 0 and 75 in our lower half, and I'm going to cross them off, lowest and highest, and then 48 and 72, 59 and 72, 61 and 71, and we have a Q3 value of 67, or excuse me, a Q1 value of 67. Q1 is the one that comes from the first half of the data. Then, if you look at the second half of our data, we're going to do exactly the same thing. The lowest point in the second half is 75, and I'm crossing that off with 100, and then another 75 and another 100, 81 and 95, 84 and 90, and that leaves us with a Q3 value of 84. 84. So at this point, we have actually completed our 5-number summary. And in a simple box and whisker plot, that would be all we need to do, but we need to do a little bit more. And in order to do that, we are going to find the IQR. Now you are probably asking, what on earth is an IQR? IQR stands for interquartile range. And the interquartile range is simply Q3 minus Q1. That 3 and 1 should both be small, but I can't superscript in the way that I was typing that. So it's just our Q3 value minus our Q1 value. And Q3 minus Q1 in this example is going to be 84 minus 67. And 84 minus 67 is 17. So 17 is our IQR, our interquartile range. It's just the difference between Q3 and Q1. So Q3 minus Q1 gives us 17. Okay, but now what we need to do is we need to calculate outlier fences. And our outlier fences are found by doing two things. We need to begin with our Q1. And then from Q1, we subtract 1.5 times the IQR. I'm going to put the IQR in parentheses because that I looks a little bit too much like the 1. Our second outlier fence is Q3 plus 1.5 times our IQR. And what this does for us is this gives us upper and lower bounds respectively as to what we will call an outlier in our data set. So our Q1 value minus 1.5 times our interquartile range and our Q3 value plus 1.5 times our interquartile range will be those upper and lower bounds. Now, between Q1 and Q3, we have half of our data. And as I said earlier, Q1 is the 25th percentile, Q3 is the 75th percentile. So between those two, we have 50% of our data. And using this system, we take 1.5 times that difference in order to say, okay, this is a reasonable bounds for the minimum, for a minimum to be an outlier and a reasonable bounds for a maximum to be an outlier. Ultimately, how you determine outliers is kind of arbitrary. This is one of the most common rules you'll see though, so that's why I'm using it here. Some of them use like standard deviation and stuff like that. We're using this one here since it goes so nicely with our box and whisker plot. But let's go ahead and actually calculate our outlier fences. So we already know what our Q1 is, and it is 67. And then we're going to subtract 1.5 times our IQR, which we found to be 17. Now, 67 minus 1.5 times 17 is 25.5. And 67 minus 20.5.5 is then 41.5. So using this 41.5, what it tells us is anything below 41.5 is considered an outlier. Likewise, when we start thinking about the upper bound for outliers, we begin with 84. And then we add 1.5 times 17, which is, of course, 84 plus 25.5, which then equals 109.5. And anything above 109.5 is considered an outlier. And remembering the calculation for this, if you can remember the 1.5 and the times the IQR, and then remember that you need to use the Q1 and Q3, it should be relatively straightforward to remember these formulas, because if, for example, you accidentally use the minimum instead of Q1 and you subtracted 1.5 from it, you'd probably look at it and say, wait a minute, it's not possible for there to be any outliers if I subtract it from the minimum. So then from there, you'd probably go up to Q1. And you can probably remember to subtract from Q1, because if you accidentally add 1.5 times the IQR to Q1, you'll end up basically saying almost the entire data set is an outlier. A similar set of reasoning should work to help you remember how to use Q3, and that being 1.5 times the IQR. All right, so now we have our formulas and we have our upper and lower bounds. Those upper and lower bounds being 41.5 and 109.5. And what we need to do is we need to check to see if any of the values in our original data set fall above or below these given numbers. And if we take a look at our data, we'll probably find relatively quickly that there are some values. If we look on the other end, our maximum value is 100. 100 is less than 109.5, so we have no upper outliers. If you look at the bottom of our data set, though, 0 is well below 41.5. So 0 is in fact an outlier. 48 is above 100, is above 41.5. So it's within our range of expected values from 41.5 to 109.5. So it is not an outlier. Our only outlier then is 0. All right, now we're very nearly done and ready to actually graph our box and whisker plot. But there's actually something we need to think very carefully about. And I'm going to go ahead and make a little adjustment to my minimum as currently written. All right, so the small little change I'm going to make to this data set is in parentheses next to my 0 here, I'm actually going to put a 48. And the reason why I'm putting the 48 here is because while 0 is in fact the minimum value of our data set, when we're constructing our box plot in our next video, you're going to find that we're going to treat 48 like it's also the minimum value at the same time, because outliers get a very special treatment when we're creating a box plot. But you'll have to wait to see that in our next video.